Well, good morning and good afternoon for some of you. My name is Jennifer Joyce, and I am the Regional Vice President of Sales for the Western Territory here at Condusiv Technologies, coming to you today to talk about how we can boost SQL performance by 30% or more. So quick housekeeping items. This webinar is really broken out into two parts. The first part is really the thought leadership portion, where we're going to just dig under the hood, talk about some of the I/O inefficiencies, the I/O degradation issues that are occurring in the environment, particularly running SQL, particularly if you virtualize those workloads. And we're just going to take a pretty close look at how and why the underlying storage subsystems are having to work a lot harder than they really should be, and why you're getting some of that performance robbing experience that you may be experiencing in those environments. The second part is really going to start digging into the performance I/O penalties that are occurring and exactly what we can do to resolve them to help boost that SQL experience for you. And obviously the compelling event here is getting that higher level of performance and SLA back to your end users without having to go in and do major forklift upgrades of hardware or a lot of other kind of disruptive and very costly remediation to try to recover performance in your environment. And on the line with me is my partner in crime, Howard Butler. Howard is the Senior Director of Systems Engineering here at Condusiv Technologies. And for any of you car fans out there, if you ever get a chance to get on a one-on-one call with him, not only does he specialize in accelerating performance on computers, he is also a race car instructor. So Howard, I'll turn it over to you for your introduction here.
All right. Well, thanks very much, Jennifer. Always glad to join you here on one of these webinars. And by the way, guys, don't let Jennifer's title fool you. She's quite technical, as you'll see as we get going along here. But there was one thing I wanted to mention, Jennifer, and that is we do like to make these sessions rather interactive. So, guys, there's a Q&A box here on the webinar, and as we go through the session, if you do have any questions, please write them up and we'll get to them either during the session or towards the end. And I think that'll make things rather smooth. So thanks, Jennifer, for inviting me.
Yeah, thanks for joining us, Howard. A couple other quick items. So as Howard said, let's keep it interactive. As you have questions, drop into the Q&A box. We often take those questions during the middle of the conversation, the presentation. Also, for attending today, you will be receiving a free copy of our software. We'll hand it off to you after the webinar is over so that you can experience the software for yourself. Also, the session is being recorded, so if we end up running over by a couple of minutes and you have to drop off at the bottom of the hour, rest assured you will get a copy of the webinar. You will also still get your free software if you had to jet out a couple of minutes early. So let's just dive right in here and get right to it. Some of you may or may not have heard of Condusiv Technologies before, and you may be kind of wondering, well, how does this company feel they're in any kind of a position to have thought leadership or even be speaking about the subject that we're speaking about today? I personally don't like to belabor this slide, but I also want to know who I'm talking to, so we'll just jump right in on this. We are a 38-year-old software company. From what we can tell in our research, we are the 12th oldest software company in the world. We're still trying to translate that to dog years. I don't think we have that equation worked out yet, but we've been around for a long time. We started out as a company named Diskkeeper. Now, some of you may have heard of that. Some of you may have used that software in the past, still may be using it today. But about 6-7 years ago, we really revolutionized and brought some new intellectual property into the marketplace that had absolutely nothing to do with our legacy defragmentation software. It was really about how could we cut out and reduce the noisy I/O, just the unnecessary I/O. And as it turns out, on any given Windows and especially SQL Server, there's about 30 to 40% of that I/O traffic that is just pure noise. It's just stealing IOPS, stealing throughput, stealing kind of transaction speed rates. And we're able to take advantage of the environment to really have our software go in there and kick that performance back up and get rid of that drag that's in the environment. We find that we're able to offload as high as 50% of I/O from storage, and we're getting a minimum of 30% faster gains on SQL, sometimes even double. Now, for this to work, we actually had a new product launch, and when we did that, Gartner named us Cool Vendor of the Year because nobody can do what we do. They didn't even have a quadrant to put us into. We've had phenomenal uptake in growth on that. We've got over 2,500 mid-market to large enterprise customers, and various parts of our software are OEM'd by a lot of the big players you see on the disk here, the Samsungs, Lenovo's, Western Digitals of the world. So we've got, millions and millions of our copies of our software out there. You may not have just seen it under our name because it's private labeled under the OEM partners that I've mentioned. Also significant is the fact that we are Microsoft SQL Server IO Reliability Certified. We'll talk a little bit more about that, and then VMware TAP partner and a Microsoft Gold partner. But Howard, let me actually come back to you on that certification, because that was a pretty elite certification that we got, if I'm not mistaken.
You're right, Jennifer, and I do consider that a rather elite certification. Microsoft has certain criteria to make sure that other applications, like ourselves, are fully compatible with their software, in this case SQL Server. And as you said, we're the only software vendor in this group here. But we're in good company with people like EMC, Dell, HP, and others. So besides all the testing that had to be done, we also had to go through a panelist of SQL experts to get past this. So I do consider it a rather significant accomplishment to kind of pat myself on the back there.
That's awesome, Howard. And just let me get a couple of shout-outs in our Q&A box. If a couple of people could just drop in a hello, loud and clear kind of thing, so that we know that we've got good connections going on here. That would be great. But let's go ahead and jump into a couple of really research elements that we had done in the environment. So we've got we've done this survey for 4 or 5 years in a row now, and typically we have about 1,000 respondents come back, and we're asking questions about SQL and just performance in general, and where are you seeing your most sluggish performance. Slow query, slow performance, batch ops taking too long, that kind of thing. And what we can see is that around 28% of respondents do come in saying that they have some sort of an issue. So we've got a lot of people coming in saying, yes, I've got SQL issues. It's around 28%. And that's been true for every year. It's either been like 26, 27, 28%. It just keeps creeping up just by about 1% every year. So the problem isn't going anywhere. And when we really kind of dug in a little bit more and we said, of all of your applications, and thanks, Ravi, for confirming we've got a good connection here, but when we look at this and say, of all of your applications, what's causing you the most headaches, and SQL kind of in our word cloud by the largest font going to the thing that was responded to the most, we really have kind of that SQL just rising up to the top, along with a bunch of other database type applications that you can see there. We would say that on average, 7 out of 10 new customers that become our new customers do so because of SQL. And once they see what it does on SQL, they start looking at other applications running in the Windows context as well. But this really is the place that has the most resonance. Now, let me just jump onto this next slide here, and we're going to just get right into the meat and potatoes here. I think that we've had enough of the setup. So before I give you an idea of what the degradation looks like, let me just start with what an optimal I/O profile would look like. I realize this is a rudimentary extraction. It's a little bit oversimplified, but I think you can get the main takeaway here is that what we're looking for is nice, large, clean, contiguous writes and reads. You can see that you're getting a healthy payload of data for every I/O operation. You can notice how nice and sequential the nature of your traffic looks. This is an optimal environment to get optimal I/O performance from your underlying flash hybrid or disk storage. But the moment that you take a SQL server and you virtualize it, you're going to run into even more complexities and more problems, especially with the Windows OS. So what you end up with is something that looks a lot more like this. Now, I think the takeaway from this is pretty obvious as well. Suddenly now in this environment, there's this I/O characteristics that are much smaller, they're more fractured, they're more random than they need to be. And I kind of have termed this a death by 1,000 cuts scenario, where your underlying architecture is processing workloads, but ultimately having to work much harder than it really needs to. It's kind of like pouring molasses all over your flash and your hybrid drives. It's penalizing storage performance, and we kind of call this the perfect trifecta for bad storage performance: small, fractured, random I/O characteristics. Now, a couple of comments I'm just going to make on this to add on here. One is, that most environments are really over-provisioned now. There's a lot of flash out there. We've got 100,000. In fact, Howard and I did an evaluation recently in an environment that had 600,000 IOPS and an all-flash pure storage. Only 11 physical servers attached to it, and they were still missing SLAs because of the nature of the workload. We installed, we recovered it. So, there's a lot of perception that the disk used to be the weak link. That's still true. The disk used to be the weak link, and today it's not so much anymore. What's happened is the fact that the Windows OS is the weak link is now starting to be exposed by the fact that the disk really could be doing a lot more than it is. Windows is holding back and not sending that data through. So with our software, we are server-side optimization. It's 100% software. It installs right into the Windows operating system, and we're addressing that now upstream bottleneck or weak link effect. So the other thing I'll mention too is that we're focused on the work that's actually being done. So if you're sitting there with 100,000 IOPS capacity, you're probably only using a very small percentage of that. So looking at all of that available space above it, that capacity above it to process more IOPS, isn't really going to help you much if the 2%, 5%, 10% of your IOPS capacity that you are using is being slowed down, and it is. Just the fact that you have all that potential above for it to burst doesn't make that workload that is being done go faster, and that's what we address, getting that to go 30 to 40% faster, increasing transaction speeds in that zone. So I just wanted to touch on that real quick because that question comes up a lot. So now if we dig under the hood and see what's actually going on and what's causing this, we can see that there's actually two different, I guess what we would call IO penalties that are occurring that are penalizing your performance and causing those IO characteristics to break down and degrade. Now the first one is what we're going to term the IO blunder effect. I'm going to start kind of at the bottom first. So the IO blunder effect, it's likely that you've heard that term. It's a term that we helped Gartner coin about 6-7 years ago when virtualization was really coming across the landscape. The IO blunder effect is what happens the moment that you virtualize more than one server and you put more than one server on a host hypervisor. So you're moving away from that physical relationship, that one-to-one relationship between server and storage. The moment you do that and you add another VM to the host, there's really no fix for what happens apart from our solution. So as great as virtualization has been for server efficiency, one of the biggest downsides has been that it does add complexity to the data path. And what happens is that the host hypervisor now mixes and randomizes otherwise sequential IO streams and now delivers to storage a much more randomized pattern. At the moment that you add a third VM, a fourth VM, you're just amplifying the effects of that. And this is really interesting. Howard, you and I just got off a call with a customer that's concluding a proof of concept we're doing. And that was just this morning. They did a proof of concept in 2 phases with us. And I'm going to touch on this right now as well, because I'm maybe jumping ahead a little bit, but this talks about how the best practice is to evaluate our software. You can install Velocity on just the SQL server you care about. In fact, this customer did just that. They have a 6-host cluster with 120 SQL servers on it. They have a different cluster of 15 hosts that handles all their dev servers, their app servers and their web servers supporting those SQL servers. So these 120 servers, there was one customer they really cared about. They just deployed us on a handful of servers that affected that customer, and the first month we were on, they made their SLA by 3 minutes for the first time in a year. The next month, they turned us off. They missed the SLA by 5 minutes. The next month, though, we encouraged them to not just focus on the servers supporting that one customer, but to go to all 120 VMs to get rid of this IO blunder effect. And we did the review with them this morning. And this last SLA round, they had us on 100 of the 120 servers, and they made the SLA window by 17 minutes. So that was by addressing all of the other workloads that are indirectly not connected to the customer they cared about, but they're indirectly connected because they're sharing the same back-end resource. It is such a powerful thing. So you may not think that installing on your XYZ server or your domain controller or whatever it is sitting over here doesn't have anything to do with the server you care about. It actually does when you're in a virtualized environment. So you can start out by just deploying to the targets you really care about, but you also may want to seriously consider that universal approach to help mitigate this IO blunder effect. Now, that's kind of an interesting thing. And Howard, I know just coming to you real quick, I know we've seen that over and over again in the evaluations that we've done. And a good example of that was actually another customer on a much bigger scale with 2,500 VMs. They went P2V overnight, kind of, and that was with Christus Health. Normally, people don't go to P2V like that all at one shot. It's gradual, or they start incrementally adding more VMs over time, and that slow creep, they're not seeing it. But this was a special case. And Howard, I believe you were directly involved with that deployment. Would you give us a little bit of insight into that one?
Sure. Thanks, Jennifer. You know, kind of with Christus, they did their testing on individual systems like many of you would do. And they expected that when they went from physical to virtual, they get the same kind of performance. But when they did virtualize all those systems, they did not get the kind of performance they were expecting. They saw a performance degradation, and that was mostly due to the fact, through their analysts, or they're looking at their environment, they found that it really wasn't a CPU problem. It wasn't memory. It really was this I/O bottleneck, this blender effect that Jennifer, you've been talking about. And that's really what caused their issue. So their first reaction was, geez, we're going to have to upgrade all of our storage, and we're going to have to go to an all-flash type of array to kind of solve that bombardment of I/O traffic. But before they did that, they got a hold of our software. We worked with them, and what we were able to demonstrate and prove to them that we were able to solve that I/O bottleneck, that blender effect that Jennifer spoke about. So rather than spending the $2 million+ that they were looking at for this all-flash type of storage array to support the 2,500 servers, we were able to save them from that excessive hardware upgrade and solve the problem just as a software solution that improves the efficiency of the Windows file system.
Yeah, thank you, Howard. You know, and just a quick note, we're probably going to be getting into the content here in just a moment where there are going to be questions. So just a quick reminder, if you're thinking of the question, probably somebody else is as well, so go ahead and drop them in the box there as we go. But, you know, we've got over 20 case studies published on our website. Christus Health's case studies out there. You certainly can go and find additional case studies for the environment that probably would align to yours. But as difficult as that I/O blender effect penalty is, there is even a worse penalty north upstream happening just a little bit more upstream at the top of the stack there. And that is from the Windows operating system itself. Now, you may be joining in a little late, or you may have heard allusions to this at some point, but we're the ones who can actually explain it because we do have the proprietary, in fact, the only proprietary software to be able to solve this problem. And that's the fact that the Windows operating system simply isn't playing well with the data. I think that, you know, if Windows didn't have as many problems as it did, probably half of us on this call today wouldn't have jobs. But we're here to help alleviate the performance and some of that issue. So there's some severe inefficiencies in the handoff of data between the Windows OS and the underlying storage, and there are no APIs that connect the two other than using the rudimentary framework that Windows has always used by addressing the logical disk to write data. And Howard, this creates a real serious problem because, you know, by addressing with Windows system, the Windows file system addressing that, any given file should be written and read with just a couple of IOs, minimal number of operations. Windows ultimately takes, though, any given file and breaks it down to be much smaller than it actually needs to be at that logical disk layer. And ultimately what happens is you end up in a situation where you're processing many multiples of IOs for a single file that really could be written in just a couple. So Howard, maybe you could tell us just a little bit more about what's actually happening here and why Windows is so inefficient in that data handoff.
Well, the Windows file system more or less takes a one-size-fits-all type of approach, Jennifer. When a file gets created or extended, the Windows file system doesn't know how big it's going to be. And so what it does, and this is on the logical side of the Windows system, it looks to the next fixed allocation, and if that file extension is bigger than that segment of free space, it'll write or fill in that space with what it can, and then it goes and grabs the next file allocation or free space. And it continues on down this path of let's say it's trying to write a megabyte of data, but the next available free space is only 4 kV. You can't put a megabyte of data into such a small area. So again, it fills in what it can, and each one of those individual segments of the file requires a separate I/O operation. So what you're really getting are all these tiny, random, small type of I/Os rather than nice, larger, sequential ones. And later on, we'll go in to show you how we solve this. But as you can see, now you're getting all these random, small I/Os coming from the Windows system itself. And if you ever look at the benchmark scores for any type of storage device, whether it's SSD, flash, or traditional spinning disk, the manufacturers always give you different sets of numbers. They'll give you measurements for random I/O and sequential I/O. And you'll always notice that the nice sequential I/Os outperform those that are random. So if we can enforce the behavior of the Windows file system such that it can do these nice, larger sequential I/Os, you're going to get the best performance out of your storage.
That's really a good point that you make there, Howard. And a good example, I think, of this is another case study. And don't worry, I have not changed the slide in 5 minutes. That's true. I just got a comment in the private chat room on that. But we'll advance here shortly. We had a lot to cover here. But it's interesting because we did a deployment with University of Illinois, one of our published case studies. And for this one, their hardest hitting database was actually running on Oracle. And they also had some other SQL databases that were having some performance degradations as well. They were running a compelling all-flash array for those workloads to meet their SLAs to their end users. And they started missing the SLAs over time. It had degraded and just really started slowing down. And they were going to turn to buying more hardware to meet those SLAs. But in their research, they came across us, deployed us, and recovered the performance immediately after deploying us. So there's a lot of other ways to go about this with a non-disruptive software-only approach. Now, let me go ahead and move on to the next slide here. So, I mentioned that both Howard and I would give you just a quick overview of what our software does, kind of moving into the second part of the conversation here. And we'll talk about the handoff of that NFR and some of the best practices for doing the testing. So real quick, as I mentioned earlier, V-locity is a 100% software solution. It is designed to optimize, streamline, and reduce the amount of I/O. It is set and forget. Once you've installed it, you don't have to touch it again. It installs right into the Windows operating system. The nice thing about that is that it means that it's not tied to your host or any kind of pooled hardware of any sort. It is living inside that Windows operating system and nested there. It's fenced by it. So it's a very thin filter driver. It's nominal overhead. We like to call it near zero overhead impact. And we challenge you to even see the CPU footprint of what we're using. It's super, super lightweight. And the CPU resources it does use run at lowest priority, so it's never interfering with your server performance. Now, what the software is doing is really two things, but those two things ultimately result in offloading I/O from the underlying storage, and then at the same time with whatever I/O does remain, as Howard mentioned, we're streamlining that I/O traffic, so it's a really friendly I/O profile for your storage to process, that much more sequential nature. It's just a lot faster to process it. And the couple of things that we are doing to accomplish that are through two patented engines. So we'll jump right into the first one here. So Howard, let's start on how we optimize writes. Now, we are already talking about how Windows has this issue where it's only looking for the next available allocation at the logical disk layer, whether it's the right size or not. Howard alluded to that earlier when he was talking about, if you've got this 4 KB space to use. Now, we'll give Windows a little credit here in the sense that on a very freshly formatted drive, this probably isn't too much of an issue. But over time, that allocation starts to degrade and the free spaces are not quite able to support that nice sequential traffic. So at the beginning you get nice, large, clean, contiguous writes, but as time goes on and files are written and erased, rewritten, extended, that's where the issue of degradation really starts to creep in. And, kind of going back to what Howard was saying, if you're trying to write a 64K file and the next available space is only 4K, it's going to fill that. It'll split, find the next available allocation, fill it, split, rinse, and repeat until the entire file is fully written. And Howard, we have a patented technology that can actually solve that problem and make sure that we are delivering with every file's optimum I/O density. So would you share with us just a little bit of what kind of intelligence we are adding here to really, coach or ensure that the Windows operating system is doing this type of optimization on the writes?
Sure thing, Jennifer. So as I said before, the file system doesn't really know how big a file is going to be when it's being created or even extended. And, as you were saying, the behavior of the file system is that it just simply looks for the next available free space. Well, what we're doing is something, rather simple there. In the background, we're able to monitor the behavior of the system, and we're saying to ourselves, hey, this file type or this particular application, when a file is getting created or extended, we know from our behavioral analytics of that data that we're seeing and so forth, we know exactly how large that file is likely to be. So we can just simply feed that intelligence back to the Windows file system. So now the file system has an idea of, it can see this file creation coming in or this file extension. It now is armed with the data it needs to know what space, where's the best segment of free space that it can allocate. So it now winds up being a very nice sequential write rather than all that jumbled mess that we talked about earlier. So it's very simple to see that we're just providing the intelligence to the file system so it can do a better job. And I kind of like to use this analogy. If you wanted to carry a gallon of water from one place to the other, think about this. You could do it with 100 individual small Dixie cups, and just kind of go back and forth and back and forth and back and forth. Or wouldn't you think it'd be more efficient if you just carried one big gallon jug and moved all that data at once? That's what we're helping the file system to enforce. Nice sequential writes, which is going to be more efficient and more optimum, Jennifer.
Thank you, Howard. So I think the net takeaway here is that kind of the intelligence that we're feeding into Windows is helping it get that best allocation at the logical layers. And since the next available space is rarely, if ever, the right size, we're able to add a lot of efficiency into the environment. Now, you notice we're not really focusing on the hardware layer here because we are living in that Windows operating system. And as I mentioned, now the Windows operating system is the weak link, and this is how we're fixing that kind of holding back effect. Now Windows can actually send out data a lot faster, a lot more sequential, and let the hardware do what it's designed to do. So you'll get that ROI out of that hardware investment you've made. Now, as powerful as this engine is, and it is very powerful, the second engine adds a huge kick into the environment as well, and this is a read optimization engine called IntelliMemory. This engine is very, very different from the first one. This is actually a DRAM read caching engine that we're establishing a tier 0 cache strategy in your environment by simply leveraging the idle available DRAM sitting there on any given VM or physical server. And we're just utilizing any of that memory that's just sitting there idle and free, that's going unused, otherwise wasted, and we're putting that into service to serve a portion of the hot reads. So you could think of that first engine of IntelliWrite getting you back to out-of-the-box performance, getting us back to 0. You can think of this engine as now putting on the booster rockets and getting us another 30 to 40% acceleration above native new out-of-the-box performance. So on this engine, the real genius of it is that it is completely automatic. You don't have to carve out or allocate any memory for cache, and the software is aware moment by moment of how much memory is unused at any given moment. It's only using that portion to serve hot reads. So that way you're never having an issue of resource contention. You never have to worry about memory starvation because the intelligence of this engine is just completely dynamic. So that really is a very important aspect of this. Now, one other thing that comes up a lot, too, is when someone starts hearing caching, they think capacity intensive to really take advantage of that and be effective. But, Howard, with our algorithms, that's simply not the case. We have found that if someone's just maintaining an average of 4 gigs of available free space on most servers, that is more than sufficient for us to offload 20, 30% or more of that read traffic. It's not about being capacity intensive. With our behavioral analytic engines, they're so powerful that we can leverage just a little bit of DRAM, keeping in mind that reading from memory is going to be 10 to 15 times faster than reading from an SSD. So just that little bit of capacity can go a long way. Now, I realize I'm speaking primarily to a SQL crowd here, and we're dealing with some pretty big servers with some pretty heavy workload. You've already got a ton of memory on those. Some extra free memory isn't going to be a challenge there. On those really big servers, I'd say go as high as 16 gigs, if not more if you have it free. But if that's a challenge, we can certainly go on the lower side and still get you some good benefits. So Howard, is there anything else that you would like to add on about our IntelliMemory caching before we move on to the software handoff?
Well, I think there are two things that makes our IntelliMemory caching rather unique. And it's one of the reasons why many of the top PC OEM manufacturers license and use our technology. And of course, you probably haven't heard of us because they license the technology under their own name. But the two things that you've indicated is dynamic memory usage. And we're only going to use memory that's currently free, available, and unused. So we're not going to consume memory or take memory away from other applications. It's memory that Windows isn't using, your applications aren't using, Windows isn't threatened by any type of memory starvation, and so forth. And the second part is that with our intelligence and what to put or keep into the cache is based upon what we feel would be most beneficial. In other words, we're not populating the cache, crossing our fingers, and hope that we made the right choice. We know from empirical evidence, based upon the behavior of your applications right here, right now, or at this particular time frame, we know precisely what data is being accessed most frequently, and we can populate the cache with that information. So again, this helps us ensure that we get the highest cache hit rate with the least amount of memory being used. Another couple of things that we can look at is, if we can actually get rid of those small, tiny, random reads and satisfy those from memory. Think about this. Those are the ones that are frequently occurring, okay? If we can satisfy them, well, memory-to-memory data transfers are roughly, as Jennifer pointed out, 10 to 15 times faster than going to flash or SSD. But equally important is the fact that those IOs did not have to go down to storage, which means that there's fewer IOs competing for storage IO bandwidth. So again, if we can help eliminate some of the noisy, unnecessary reads and writes, and we're only caching those reads, then we can greatly reduce the amount of work hitting the storage. And as a result, the storage system now has more bandwidth to handle the IOs that do need to go to storage, such as those non-repetitive reads or writes. So I think that just kind of helps, Jennifer, people to understand the importance of offloading IO traffic and increasing IO bandwidth capability.
Great. Thank you, Howard. Now, we do have a question. We'll get to the Q&A here in just a moment, but if there are any other questions, we have covered as much as we're going to cover about how the technology works. So if you have any compatibility questions, deployment questions, licensing questions, start dropping those in now because we're going to be wrapping up shortly, and we want to make sure that we have a chance to answer those questions for you if there's any floating around. So, really you can go to our website. Like I said, we've got over 20 published case studies. A couple of highlights real quick. We had touched on Christus Health. They actually had a PO sitting on the CIO's desk for signature for $2 million to do a forklift upgrade 18 months into the hardware cycle that they had, they canceled it. And I had a chance to have dinner with them at VMworld, and I asked them, is that a true story? And they said, absolutely, every word of that is true. So that was pretty neat. These guys also were sitting on about a 350K hardware upgrade, installed our software on their ERP, Epicor, and all the performance problems were gone by the end of the week. They were good to go. These guys, and I did that deployment. This one I also did where they had SQL batch imports taking 27 hours, drop down to 12 hours, and there's more. There's also kind of what I call, these guys were what I call the Windows shadow effect, just all those niggly, glitchy little things that pop up in an environment that are annoying. Those tend to disappear when our software is installed, and I've had multiple customers just in the last couple of months who've become new customers come in with exactly that use case of, 30% of the stuff that we used to have to deal with is just gone, not having originally associated to being I/O issues because they were impossible to diagnose. So some pretty neat stuff does happen. I'm not going to go ahead and do this. I know we're running a little bit over time here, so I'm going to go ahead and pass this and let you guys take advantage of being able to go to our website and check some of these stories out. I do want to show you briefly what our UI looks like. So if we're looking at that, you can see that on average we do eliminate about 30% of all write IOs. How it writes is how it reads. And then we also, this is a little higher than our average. Our average is about 50% read IO elimination. So the dashboard is going to tell you a really compelling story. You're going to be able to see that right there. And then you're also going to be able to see a lot more of the analytics and data inside of that software. We do have a central management console, which comes free bundled with the product that you can use to deploy. It's a .msi, so if you want to use your own methods to deploy it, you can always use the console to come back for the really high-level and deep dive reporting that are provided there. So I am going to go ahead and jump right into some of the best practices for the evaluation. Now, as I said, on step one here, DRAM, you probably already have enough. On SQL, you may want to consider placing a memory limit so that SQL is not consuming all of it. As you know, SQL will do that, and that you leave some free on the OS side for us to cache with. And like I said, 95+% of all servers already have enough memory on them. It's just a matter of maybe moving that SQL cap a little bit to accommodate the benefits of the velocity caching. And then you simply monitor the dashboard. A week later is a good time frame to look at that. And the handoff of the software as well, and we'll go into Q&A here in just a second, but the handoff of the software, we're going to be giving you an NFR. This is a fully licensed copy of the software. You can deploy it on any one server that you want. It would be a physical server or a virtual server. And then we also want to make sure that if you're running SQL, that we've got the proper memory limits in place on SQL. But the other option too, and this goes back to the evaluation that we just wrapped up this morning with this one client where we, got a limited benefit on deploying to 10 of their servers. We made the SLA the first month, and then they turned it off, missed the SLA, and then they put it on 100, servers of 120, so they were on 90% of their environment, and then they really made their SLA. They had an extra 17 minutes of room to breathe. I personally like going that route. So we kind of did a staged approach where we just did the area that they were most concerned about, and then we did that alleviation, kind of that rising tide raises all ship approach, and just go everywhere with the software. Now, we will enable you to do so through trialware. We will give you a full copy of the VMC, which is the Velocity Management Console, and the ability to deploy Velocity to as many VMs in your environment as you want. In fact, you can deploy them to all your VMs if you would like to really see what the software can do during your trial period. We also have a pre-assessment tool, which is not on the slide here, called the Condusiv IO Assessment Tool. It is free. It does not require installation on your target servers. It just uses remote WMI calls to collect existing Perf1 data from those target servers so we can even see if they're good candidates in the first place. So in the chat box, you can type in both, or you could type in VMC, or you could type in IOAT. So if you want that assessment tool only, just type in IOAT. If you want the Velocity Management Console with the expanded trialware, type in VMC. If you want both, type in both. We'll make sure that our team gets you what you want after the session, and you will still be getting your free standalone copy of the software to use. So I'm going to go ahead and hop into the Q&A now. So the first question is from Adriana, and it's, so if our Howard, this question's for you. So if our applications are actually running on a Unix server, Linux, and are directly connected to the SQL Server database running on a Windows server, does that still create the random patterns of I/O files?
It really does. Our solution set is really focused on the Windows side of the equation. and depending on the number of Windows instances that you're running, you will have a level of I/O inefficiencies that is incurred by the Windows file system that we can help clean up and take care of. But you will still see this even if you're running in a Linux environment. And even though our software is really Windows focused, anything that we do on the Windows side of things in that shared type of environment is going to naturally help and improve the behavior of Linux, even if our software is not installed on that Linux system.
Great. Thank you, Howard. Eric has a question. I'll answer this one. It says, does this work with Hyper-V? So, Eric, yes, the software is hypervisor agnostic, so you could be on KVM, Citrix, Hyper-V, VMware. Where we install is directly on the Windows VMs. Technically, you could install our software on Hyper-V since that is Windows-based, but we found that the VHD files are not degrading enough for us to deal with the right optimization there. We also found that the read caching is most effective in the VM rather than at the host level where the VM has direct visibility to what that read traffic is like. So your question may have been twofold of should I also install it on the Hyper-V host? You can, but we, at this point in time with the current state of our product, have not found a significant benefit. You would still install it just on the individual VM instances. Howard, is there anything you'd want to add to that answer?
No, I think that covered it.
Okay. Ravi asks, if I understand correctly, this technology can be implemented on any COTS application with any RDBMS. Am I right? Howard?
Yes, indeed. You know, it's really Windows is Windows is Windows. IOs are IOs are IOs. And, you know, whether it's commercial off-the-shelf type of application, custom-written applications, relational databases, you know, they're all running within the confines of the Windows file system. And that's where we sit, live, and breathe. That's where we provide the improvements there. And so any and all of your applications, if they're compatible with Windows, they're naturally going to see a benefit with our product.
Great, thank you. Now, Brian asks, do you have any positive results with Velocity on MS Exchange servers? And the answer to that is yes. We have seen a lot of positive results in that space. And this is another application. There's really two. There's SQL and Exchange where memory limits are appropriate because Exchange is the other application that will kind of hog all the memory. If it's there, it'll use it. That also opens up another interesting question depending on how you're configured. But since you have the OST and the PST relationship between the client installs and Exchange, we actually have a lot of people use us on their clients as well to help keep optimization of local client-side data. Howard, is there anything that you would want to add to that?
No, I think that covered it. That's good.
Okay. So Randeep has a question. Will the recording be available if I want to share it with my DBA team? Yes. Everybody will receive an email with a link to the recording. So yes, that will be available for you to replay. Brian asks, does Velocity require a server reboot after installation to get started? And I have to celebrate on this one and say, no, it does not. Our earlier versions did. It was a major, major release with Velocity 7 that we are now able to install filter level driver technology with the gold certification by Microsoft without a reboot. And Brian, I'm sure someone on the call, if not you, is thinking right now, what about deinstalling it? Can we do that cleanly without a reboot? And yes, that can also be uninstalled without a reboot very cleanly as well. Eric asks, is additional memory needed per VM or for the whole host? Howard, let me flip this question over to you.
Look, most servers will already have an abundance of idle, unused memory, but for those few systems where maybe you're already at a memory usage capacity, it might be needed for a few of those virtual machines to add more memory. And actually where you're getting that memory from is going to be memory that's unused or unallocated from the host. So depending on, you know, what your memory configuration is on the host and whether or not you have enough memory available on that host would really dictate whether or not you can allocate more memory to each of the guest VMs on an as-needed basis.
Great, and let me add on one thing to what Howard just said as well, and that is that if you're memory bound, you're on an older host, you can't add any more memory, and let's say that natively the VMs you have isn't enough. First of all, probably what you have is already enough, but in the rare instance where that isn't enough, then we simply will not be providing as much benefit. Having that memory is not a requirement. It certainly does help, but you're still going to get all of the right optimization benefits, which do not require any memory whatsoever. And then if you do have limited memory, we'll be able to put into service what's there. Even though we could use more, we'll still do okay with what you have available. So that's definitely not something that we really worry about too much. Now, we are coming down to the last question, so we are going to be shutting down the WebEx room here in just a moment. So if you have been holding on to a question, please do drop that in right now. If you have not yet typed in both or IOAT or VMC, please type that in now so that we can make sure we capture that. And let me hit in here real quick to the last question. And actually, everyone started putting in their requests, so my screen moved up. Howard, do you still have visibility on Brian's last question? I didn't get to see it.
Let's see. I think after Brian's question, there was a question from Eric. It looked like how is server-side caching different than what SQL does with memory already? And that's a really great question. I mean, SQL does have some level of caching, but if you think about this, it's caching with blinders on because it's only thinking and concerning itself with the I/O traffic that SQL is doing to the data stores and transaction logs and whatnot. That is not all of the I/O traffic that gets generated from that Windows server. And depending on how you have things configured, there may be other applications, other workload threads that are doing as much as I/O as the SQL server itself is doing. So we take a more holistic approach. And if the SQL server side of caching doesn't have the data it's looking for, it's going to queue up an I/O request. And if we see that I/O request and it's repetitive, then guess what? We can cache it. So you're not getting a doubling up effect. You're actually getting kind of, if SQL misses the read I/O request, you have an alternative to where it still can be satisfied from memory due to our enhanced algorithms. And we're not limited to just SQL only. There are all kinds of other I/O requests that are happening throughout the day that matters that we can help eliminate that I/O traffic from.
That's great. And last call for questions. We did get one last one snuck in by Randeep here. Does this provide benefits for non-VM SQL Server? So that's a really, really good question. I've alluded to that but didn't address it directly. The answer is yes. If it is running in Windows, it is feeling the effects of the Windows operating system inefficiency in breaking up data. It is also feeling the effects, if it's virtualized, especially since you've mentioned VM, of the I/O blunder effect of the workloads of neighboring VMs. So this behavior of inflating I/O by 30 to 40%, of kind of dragging down performance across any application running on any Windows VM is a real thing. And if you do have other targeted applications that you want to look at, and if you also just want to explore that I/O blunder effect of getting rid of 30 to 40% of all inefficiency from all of the VMs, regardless of what they're running or how heavy their I/O loads are, that has a force multiplier effect in the benefits that it provides. So that was the last question, and this has been a great group of questions. Really appreciate the interaction. And really appreciate everybody's attendance today. So we'll tie off the webinar as soon as WebEx generates that recording. We'll have marketing team will be sending that out to you along with your NFR, and anyone who's typed in that both IoT or VMC, that will also be sent to you. So thank you very much, everyone, for your participation. And Howard, a special thanks to you for your technical expertise and kind of lending your time to us today.
My pleasure. Thank you very much, Jennifer. Always good to be here.
Okay, thanks everyone. Bye-bye.
All right, bye-bye.